Okay, let's pick up where we left off in the last video. We're now on Module 1, Learning 4, Student Page E. I rewrote our rules over here so that we wouldn't have to keep turning back, just to remind you. So in multiplication and division, and that's what I should have done, is written that there. In multiplication and division, we count the number of negatives. If it's an even number of negatives, 2 negatives, 4 negatives, 6 negatives, it's a positive answer. Odd number of negatives gives us a negative answer. So if there's 1 negative or 3 or 5. So again, we're just going to continue using the rules and not use the charts to draw the chips. So here we have 1 negative. 1 negative makes the answer negative. So I do this as a two-step process, just like we did in the last video. Do the sign, then do the division. 12 divided by 4 is 3. 1 negative, again, that's an odd number, negative answer. 12 divided by 4 is 3. Okay, so figure out the sign using these rules and then do your division. So here we have another single negative, so that means 1 negative, odd number, negative answer. 8 divided by 2 is 4. So 8 divided by negative 2 equals negative 4. So same old stuff we were doing on the last pages. So let's do one more and then you guys can stop the video and do 2 on your own just to make sure you got it. So number 2, we have 1 negative again. That gives me a negative answer. 15 divided by 5 is 3. So 15 divided by negative 5. Now they're finally using parentheses. Someone new must have made this packet. And same thing with, the next 2 are yours. So go ahead and do number 3 and 4. Turn off the recorder real quick while you do them, and then join me back and we'll compare answers. Okay, for number 3, 1 negative again. So negative 8 divided by 4. 1 negative is an odd number of negatives. 8 divided by 4, 2. So the answer is negative 2. And likewise, negative 10 divided by 5. There is 1 negative. 1 is an odd number, so negative 10 divided by 5 is 2. So very, very simple. Figure the sign, do your division. Okay, so again, I'm going to ask that you turn off the recorder, do number 5, 6, 7, and 8, and then write your rules one last time, and then we'll move on to something new. So join me back when you're finished. Okay, 18 divided by 3. No negatives in sight, so that would be a positive 6 for an answer. What is negative 3 divided into negative 18? That means negative 18 must be first, and negative 3 is being divided into it. So negative 3 divided into negative 18. 2 negative signs. 2 negatives is an even number of negatives, so it's positive 6 for our answer. 1 negative sign, negative answer. 18 divided by 3 is 6. 1 negative sign, odd number of negatives, negative answer. 18 divided by 3 is 6. So just like before, decide your signs, then do your division. Okay, so let's write the rules one last time. So for multiplication and division, odd number of negatives, that means 1 negative or 3 negatives or 5 negatives, gives me a negative answer. And an even number of negatives, that means 2 negatives, 4 negatives, 6 negatives, gives me a positive answer. And like I said, the more you write it, the more chance you have of remembering it. That is proven in many, many studies. Writing things helps you to remember it. Okay, let's move on to this, and this is just a kind of a review and also to show you how to check. So did you all know, or do you remember from probably many, many years ago, that multiplication is checked with division and division is checked with multiplication? So this will show you. So we have 0 negative, so positive 12, 1 negative, so negative 12, 1 negative, negative 12, 2 negatives, which this and this should be in parentheses, 2 negatives, positive answer 12. And we can check them by dividing. 12 divided by 4, is that 3? Yes. Negative 12 divided by negative 4, 2 negatives make positive 3. Yep. Negative 12 divided by 4, 1 negative, negative 3. Yep. And 12 divided by negative 4, 1 negative, negative answer. So you can see we did all these, then we reversed the order and divided, and we verified that each of the numbers up here were our answer. So we check multiplication by dividing. Likewise, we check dividing by multiplying. So now we're going to practice on our own. We can rewrite an integer division problem as multiplication. So we're doing just the opposite. So we're getting an answer, and then we're going to check it with multiplication. So 12 divided by 4 is 3. That means that 3 times 4 must give me 12. And that is a true statement. 2 negatives is a positive. Negative divided by negative, positive 3. So that means that 3 times negative 4, which gives me negative 12, should be the number in front. It is. 1 negative again, negative answer. So that means negative 3 times 4 should give me the number in front. 1 negative, negative answer, and 12. And so you can see the pattern continues. It doesn't matter whether you're multiplying or dividing, just switch the order and you should get back to your original problem. 1 negative gives me a negative answer. 12 divided by 4 is 3. That means negative 3 times negative 4. 2 negatives is a positive 12, and there it is. So all multiplication can be checked with division. All division can be checked with multiplication by just switching the order. This times this gives me that. Fun stuff, right? So there's so many ways to check your answers. Turning it into a money problem, doing a number line, doing chips, reversing. Addition is checked with subtraction. Subtraction is checked with addition. Multiplication is checked with division. Division is checked with multiplication. Okay, so we're going to learn a little bit more about grid multiplication. So just another way to multiply. I don't know. It's just nice to have different ways to look at things. So this is a 14 by, is that 23? Yeah, by 23 grid. Or we could say 14 copies of 23, because we learned that multiplication can be read as copies. And so here it is with the grid, and we can use blocks to represent the area. So rather than do 23 times 14, there's other ways to find the area too. So 23 can be broken up into 20 and 3. 14 can be broken up into 10 and 4. So that leaves me with 2 flats, because it says base box. Remember, our flats are rods and our units. So we have 2 flats. And how many rods? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 rods. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units. So this is 12 right here, and this is 3 rods, and then this is the other 8. Okay, so flat, flat, here's 4 rods, here's 4 more rods, there's 3 more rods. So altogether we have 2 flats, 11 rods, and 12 units. So now we can do 2 times 100 plus 11 times 10 plus 12 times 1. You remember doing that before? So 2 times 100, 11 times 10, 12 times 1. We did that way back in the first unit. So this would be 200. When we multiply something by 10, remember that adds a 0, so it would be 110 plus 12. And when we add those together, and they just did it in a different order than us, but you'll see we get the same answer. So we come over here, we line up all the numbers from the back, 110 and 12. And we get 2, 2, 3. And look at that. They got the exact same answer. They did it like this: 20 by 10, 4 by 20, because there's 20 long. So they found the area of each one. This one, it counted as one big, this is one big, this is one big. We just did it using our flats and rods. But we all get the same answer. And then if we actually did the multiplication, because does everybody remember that's how you find the area of something? To find the area, you multiply the length times the width. So if we actually did the multiplication over here, 3 times 4 is 12, carry our 1, 8 plus 1 is 9. For the second row, bring down your 0 at the end, and then 1 times 3 is 3, 1 times 2 is 2. Add 2, 12, carry our 1, 322. Look at that. 3 different ways to find the area. So by grouping and doing the flats, the rods, and the units, and by doing regular multiplication. All answers the same. Cool, right? Okay, let's try another one on the next page. So we want 25 by 32. So 25 by 32. So it looks like the 32 has to be up here, right? So let's make a mark where the 32 is. So 10, 20, 30. So it's going to stop right here. And then we need 25, 10, 20, 1, 2, 3, 4, 5. So we need to mark that off on the grid. And so that's going to look like, hopefully I don't go past the 1, 2, 3, 4, 5, I think. So this is just finding the area of a rectangle that's 25, we'll say, inches by 32 inches. So we can do it by doing regular multiplication, which we'll do last, or we can do it by counting our rods and flats. So we have 1, 2, 3, 4, 5, 6 flats, and remember every flat is 100. So we have 6 flats. Now we need to count the rods. So 1, 2, 3, 4, 5. So 5 rods. Whoops. Let's do it in a different color. So there's 5 rods here, 5 rods here, 5 rods here, 2 rods here, and 2 rods here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 rods, 16, 17, 18, 19 rods. And then last we have the units, which would be this area that isn't part of a flat or the rod. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 4, 6, 8, 10. So we have 10 units right there. And now we can find the area with absolutely no multiplication required, like showing your work kind of multiplication. So this would be 6 times 100 plus 19 times 10 plus 10 times 1. And that, expanding that would be 600 plus 19 times 10. You remember, you just add a 0 when you're multiplying by 10, plus 10 times 1. Then we line all the numbers up with from the back, 600, 190, 10. And then we add, and that will be the area of the figure above. 9 plus 1 is 10, 6, 7, 8. So I know the area equals 800 square units. They didn't tell us what they are, so we'll just say units. And area is always squared. We go over that in our geometry section in Module 4. But it's always something squared, meters squared, inches squared, feet squared. So when we don't know the units, we just say square units. Okay, so now let's use the regular algorithm. If you were asked this problem on a test, most of you wouldn't take the time to do all this. We can do 25 times 32. So for that, 25 times 32, and we should get the same answer if we've done our work right. Let's hope. So 25 times 2 is 10, carry your 1. 2 times 2 is 4, plus 1 is 5. Now we're on the second row, so you immediately drop a 0 at the end. 3 times 5 is 15, carry our 1 again, 6, plus 1 is 7. Then we add to get our final area. 0, 10, carry our 1. Ding, 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 ding. We got the same answer. Cool, huh? So that just shows you the meaning of area, what fills up the region that we're doing, and it shows you that there are several different ways to find that area. So this one would also be 800 square units. That's fun, huh? Different way to find area. Okay, I think we're on our last 2 pages. And I'm going to tell you on this, I don't do all the blocks and all that stuff. It takes forever because you have to, like on this one, you're going to have to make 516 blocks and then divide them into pieces of 12 because you want to know how many 12s are in 516. So we're just going to work on the algorithm because I think that's, most of you will not have time to draw 516 blocks and break it into groups of 12. So we're going to actually use the algorithm. We'll just do it right here. So we're doing 12 into 516. Okay, so hopefully you guys remember your long division. If not, we'll try and get some of the cobwebs out here. So first we divide 12 into 5. Nope, doesn't go into 5. So then we uncover one more number and we say 12 into 51. Well, I know 12 times 4 is 48. So that's as big as we're going to get. So above the last number that's not covered, I put my 4 up here. 12 times 4 is 48, so write 48 underneath here, and then you draw the line, change the sign. So now it's a subtraction problem. So to subtract, we make this 11 and borrow 1 from the 5. 11 minus 8 is 3, and then we bring down the next number. And then 12 into 36, 12 times 3 is 36. And we get a remainder of 0. And remember what we just learned on the lesson before this. You can check division by multiplying. Because I always have students go, you know, I'm really shaky on division. And I say, well, if you have time during your test, then go back and check it. So to check division, we multiply. So we just do 43 times 12. And if I've done the problem correctly, I should get this number back. So check division using multiplication. So multiply the quotient by the divisor, and it should give me the dividend. So 6, 4 times 2 is 8. We're getting ready for the second row, so we bring down a 0. 1 times 3 is 3. 1 times 4 is 4. Add 6, 11, carry your 1, 5, 16, and ding, 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 ding. There's my number. So I can walk away and go, yes, I know I have this one right, because not only did I divide, then I checked by multiplying. And we're going to do the same thing on the back. We're not going to do the blocks. We're just going to do a regular division problem, because I think students need more practice with that than doing all the representations, because like I said, you won't have time to do that on your test. So this is a time for you. So you have to cover these up, because I did them down there to show. So I want you up here to do the division without looking at the bottom right of your paper. So you need one to practice on to make sure you're all good, and then check it over here just like we did the last one. Okay, so turn the recording off, do your division up here without looking at the ones, and we're gonna just do our standard algorithm here. So we'll just bring an arrow up from this. So we're just gonna do the standard algorithm right there. Okay, so shut off your video and join me back when you're done. Okay, so to do this one, 3 doesn't go into 4. So I uncover one more number. 13 times 3, I believe, is 39. 9 and 3, yep, so there's our number. So above the last number that's not uncovered, or that's, yes, that is uncovered, I should say, I'm going to put a 3, because placement's important. So always above the last uncovered number. 13 times 3 we just saw is 39, and then we draw the line, change the signs. 40 minus 39 is 1. And you could do your borrowing. I just did it in my head. But if you borrowed, you'd make that 10 and borrow from the 4 and make it 3. 10 minus 9 is 1. And then I bring down one more number. 13 goes into itself once. 1 times 13 is 13, leaving a remainder of 0. So that means our quotient is 31. Our answer, our quotient is the answer to a division problem. And then we can come over here and do the check. So we check division by multiplying. Is 31 times 13 going to give me 403? Well, let's see. So 31 times 13, and order doesn't matter, by the way. In division, it does. I have to, the second number is always the number on the outside, so that has to be there. And the first number is what becomes the dividend. It's underneath the division. But when we go to multiply, it doesn't matter whether I do 13 times 31 or 31 times 13, because multiplication order doesn't matter. In division, it does. So the second number is always the divisor outside. Okay, so let's check this one. So 1 times 3 is 3. 3 times 3 is 9. We have another row, so we bring down our 0 at the end. 1 times 1 is 1. 1 times 3 is 3. Add the two lines. 3 plus 0 is 3. 9 plus 1 is 10. Carry our 1. And ding, 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 ding. We did it. So we know without a doubt 31 is our quotient. And we can walk away and go, yes, I got it right. And I'll show you how to check with remainders when we get to the remainders in the next chapter. But for right now, no remainders, so all you have to do is multiply these two and it should always give you that number back. Okay, that's all for lesson 4 in module 1. So I'll see you back in lesson 5. Bye.